So welcome as you arrive into our virtual conference room for our session, which is how to reduce costs and increase profit with Inkjet, with a specific focus on Inkjet for wood decoration. I'm Marcus Timpson. I'm one of the co-founders of FM Future. We're an independent consultancy with a specialism in Inkjet for new marketplaces. Joined today by two experts, actually, and despite their youthful appearances, they've been involved with Inkjet for many years. Carsten Brinkmeyer at Timon has a track record with Kaman, and more recently, in the last 10 years, with Human as an R&D and director and now head of sales for digital. And Richard Darling, equally, with a long track record in experience in digital print with Xerox, with ZAR, with specifically developing new markets for Inkjet in an array of new areas, and also more recently, the last 3 years at Ricoh Europe, developing the exciting Satin project, which we're going to go into talking more about as we go through the presentation. I'm going to give you a little bit of an introduction in terms of some survey, and this is kind of the agenda here, which I shan't read out, but gives you an idea of what we'll go through in the next hour or so in terms of content. So the survey that I wanted to introduce you to first, just before that, the bell curve that I guess we're all familiar with. The reality is technology, when it enters new markets, goes through phases. It experienced what Moores calls the pre-chasm phase, which is the early market, and that's where the focus is on technical development, and that's an important part of the process. However, it does not mean mainstream market adoption. And what Moore says, that every technology has to cross the chasm in order to be accepted. And at that point, the focus needs to change from technical issues, because frankly, by that stage, most of those have been solved or very close to being solved, into more economic proof that the particular technology delivers against solving a particular problem. And I think that's a key thing that we've talked about here. It's about solving problems, and its first principle thinking is the right thing here, in that thinking problem first and technology second. And I think we've seen across Inkjet, generally in new markets, it has occurred where a technology has come into the market and it's been solving perhaps the wrong problem. And what I'm really confident about with this particular innovation is that it's first principle thinking. It's focusing on the problem first and the technology second. And I'm suggesting that actually, based upon our analysis and our research and feedback, that actually decor, in particular floorings, is at the point of crossing the chasm, not least because this technology addresses the specific economic reasons for adoption. So the survey that we did in May, 103 responses. It's a partnership project that we've continued with Ricoh. 103 responses across the world. Some key headlines that COVID has impacted on the marketplace. Centralized manufacturing has struggled. The old models of making products from different continents and delivering them into another continent has struggled. Global supply chains have buckled. Digital manufacturing has accelerated in terms of interest and adoption in it, because it provides significant value and flexibility that's particularly needed at the moment, because there's a big pressure on cost and profit centers. And we're asking the questions, how should markets respond? May, we've seen 20% reduction in demand. Economies have not experienced this level of reduction before. So there's a reduced demand for printing generally, and that's a reduced demand for printed products, and actually smaller lot sizes. And this is where digital has a massive role to play. When do you expect normal trading to resume? Nobody really knows, but I think most people accept that normal trading in the may never be the same as it was before, but it's when a vaccine is available. So what we're suggesting with this technology is a great opportunity to look at taking back control and utilizing this available technology that perhaps solves a lot of the problems that the market is facing right now. So We also asked respondents who were from the Inkjet community and also Inkjet users, how have you responded to the crisis? And a lot of people have taken time to collaborate and innovate. And additionally, look to reduce risk through improved processes and efficiencies. So solving particular problems that are economic is really important. But clearly collaboration and innovation and improving processes to reduce risk and improve efficiency is really key. And that is exactly what Satin enables. The next question, do you think challenges with manufacturing and retail supply chains will lead to any of the following? And this really significant, it's the most important slide. We expect to see an increase in digital manufacturing to help solve future supply problems. Reshoring will grow, decentralization of manufacturing and an increase in demand for industrial inkjet, as well as that increased collaboration. And this really is a menu for industrial inkjet and more specifically Satin. If you're in this industry, you should be looking at partners that enable something new, and the development partnership of Himan and Rico really blends the best of both worlds. So collaboration and innovation are really important, as the survey says, and there's a huge amount of it going on at the moment. This has been in development for a while, and we're seeing the fruition of it now. How important has this partnership been to developing Satin, which I think is solving the right problems right now? Gentlemen.
Well, it sounds like this is a collaboration that's a new thing, but this is actually a collaboration that's been going on for some years, and it was quite obvious that some of the developments from past times have actually missed the mark slightly. We've all been involved in some of those, but Human actually has the embeddedness to a market, so it understands the decor market, the problems and the challenges of the decor market. So an ideal partner for Rico.
Yes, and the other way around, Rico has very strong experience in water-based inkjet printing, 40 years experience of digital printhead manufacturing. For Human, it's been a good choice to start a project together with Rico, which is started in 2016 already. We bundled our engineering capacities, and it's a different, it's a real partnership. It's different to everything what Human has done before. It is we used our labs, we used Japanese labs and engineering capacity together to come to the same result, to a machine which is designed really for the market, especially for the decoration market, and therefore we did a lot of analyzing, not only in technical ways, also in economic ways, and to find out the needs. This is one thing we will speak about today, yeah, we will show up the economics, which is one of the very important things in that.
Just to introduce a term here right now, digital analogic. That's the mistake of actually trying to make a digital machine do exactly what an analog machine has done. We were expressly determined to avoid that trap, and pooling our resources has meant that we feel quite satisfied that we have avoided it.
So the application we are talking about is known for nearly everyone. I hope for everyone. So just printed paper for the melamine boards. We see that there are some criteria in quality that need to be fulfilled. We are sure we can fulfill them. But we took at first a view into the traditional way, how the production is done the traditional way. And there are 5 major decor printers supplying all over to many production sites, just a few. And they are running rotogravure presses with a capacity of 150 million square meters a year, and they supply then to hundreds of board producers with thousands of lines by trucks and lorries, and this is resulting in minimum order quantities. So they're producing an analog. They need to fill the machines. They don't want to run very short stops because analog is not made for that. And also the time it's time consuming to agree in an own design. If a manufacturer wants to have an own design, an own collection which is exclusive, he has to travel to the printer, decide there on site for the result, and then comes back again. So it is the chain, the process is not feeding the demands of smaller lot sizes, but digital printing can support and can help with smaller lot sizes and reduce the delivery times and reduce the time to market, less material in stock, and all of that. The way to get to digital printed paper at the moment are three ways. So one way could be you buy digital printed paper from an external supplier, so from a printer, but this is not really improving your workflow. This is helping the printer to be able to supply smaller lot sizes, but it's not changing anything of your workflow, which is there's still a minimum order quantity. There's still a lorry which carries on material. There's still material which is has to be placed in stock and into impregnation, and maybe it's not all impregnated at once, or you have overproduction. So it's not a workflow improvement. The second way is that you can operate in multipass printers. Many of the companies are already tested multipass printing for sampling or for small lot sizes, but it's very, very small lot sizes. Even a very fast 200 square meters per hour printer, I'm not aware of any can really do that. Could then deliver 300 square meters per year per shift, which is not much. The third way,
there's Carsten, I'll just interject there. There is still a part to play for the multipass printer in some of those kind of ultra short runs and some of the proofing exercises that go on, or specific needs. So there is something there, and also it can be important if the multipass production actually matches a single pass option, so that the output from each is matched.
The third way is to operate a single pass printing line, which is the Satin is also a single pass printing line, but the existing single pass printing lines in the market are in a way designed, as Richard already said. It's an analog copy, so they are going for very high capacity. So is that really what a board producer, a manufacturer at production end is looking for? And with the next page, Richard, we see you are looking to on per operating site. You're looking 5 to 18 million square meters. What one site is using in paper per year. You can do that with multipass printers, as I said. Then you have a very low invest in machinery, but also a very low output capacity. Or you can operate a single pass printer, which is placed to some printing manufacturers in the already. They can produce, have a capacity of 80-90 million square meters a year, but also a very, very high invest. And you see the gap of what you need and what you can do, everything in between, is very large. We are talking about 50 million square meters over capacity in that. And we decided, and that's what our survey, what our white paper, and then all the evaluation said. We build a machine which is actually made exactly for the needs of one operation site. That's the Satin line. So speed is not the issue. It's really the capacity, and the capital to invest. This will be shown in the next calculations which will follow. So the Satin line is a result of the development of Human and Rico, with slower sprint speed, same width as already in the market, standard colors, red, blue, yellow, and black, options for special colors. It's pigmented water-based ink, same pigments as in analog printing, resolution of 600 to 1200 dpi, and print heads of Rico with a through flow technology. So
through flow somebody else, Carsten. I think it's flow through.
All right. So circulating ink to the printhead, which is I think it's a must and in our experience of what we have for single pass printing.
I should emphasize there that this is tried and tested, proven technology. There's nothing new in the inkjet technology here. It's very large quantities of these print heads are already in use in markets in a variety of different applications, a lot of them in water-based, so it's nothing new. Water-based is new to the decor industry for inkjet in this format, though. Human, and I've been involved too, and glad to have been involved too, in developing inkjet into the decor market with UV. That's actually been a very important part of this, because together Human have actually put in close to 50, I think it's 46 UV inkjet installs. UV is not the preferred choice, but it has some benefits in certain niche applications. Those printers are largely at board producers. They're not in specialist print centers. They're actually at the board producers. They are producing niche products, but they're also producing 100 million square meters a year, which in the overall scheme of things is not a lot, but we're talking about hundreds and over 1,000 board producers and 50 installs. There are some other players in that sector too, with UV inkjet. Really, for water-based, the options are limited. There are a couple of printers available that we'd put in the high volume sector. They're at specialist printers because that's the only place where that volume suits so far. Unless you're a very large capacity, large volume producer of boards. And in those cases, sometimes they're multi-site anyway. So that's not really decentralized and matched and balanced to the whole production flow. They're really installed to reduce the loading on gravure presses for the short runs. The short runs are increasingly a demand of customers. So if you put the short runs, as we'll show, onto the gravure presses, you dramatically impair the efficiency of those gravure presses. Gravure presses are built for high volume, long job runs, and that's really the problem. Each of these inkjet machines, the high volume inkjet machines, as Carsten said, 90 million square meters is typical of capacity. That's not theoretically. If you could load all the jobs onto those, there's very little change time, as we'll show, and they can produce 90 million square meters. And in order to make them cost effective, they must produce close to 90 million square meters. They're operating at breakneck speeds. 150 meters a minute is clever. It's certainly a sophisticated piece of engineering to be able to do that. You can go a little faster, but that's fast, and that's not easy. They're probably not working to capacity because there still is the tendency to actually put as much as you can onto the gravure presses to feed those machines. So they're reserved for short run. It's not yet proven whether those systems are economically viable and whether the prices that are possible reflect through to the price per square meter for printed paper to board producers.
Yes, and the request for the high speed ends up in very high cost and making and stressing the reliability and yeah, when you go to a lower speed, and that's what the Satin is designed for. then we are less expensive in engineering and less complex at all.
And more reliable.
Lower speed means matched to the post process. No one really has a line running with 200 meters per minute production line. So when you end up, so even the low speed, when we call it lower speed, it is still valuable for 20 million square meters a year, which is a good number, well, a very, very good number for one production site. And I think everyone has to match it. The post process, like the impregnation line, they run typically in 30 to 35 meters, some maybe in 40 meters, but I think in the regular world, the speed is absolutely fine matched with the speed of the Satin. Correlates very good to the post process.
So we've mentioned that we carried out a lot of analysis. So first of all, on the positioning and the specification of the equipment, it was a very thorough process to determine where the best economic spot was, what the actual problem was, and as Marcus referred to, first principle thinking. So what are we trying to solve? And we did a lot of the analysis on the whole production stream from end to end, where the image is applied, where the value is applied, and what that results in from the producer of the finished product. So we looked at it both, well, before we started to make sure we got the right position and to adjust where necessary. We looked at it during the whole project, which is, as Carsten said, has gone on for close on 4 years. And then we've been looking at it since. We've gone through the technical stages and the concept stages, and we're really finishing off the detail. We produced this paper. It's a red covered white paper. So whether it's a red paper or white paper, same principle. It's supposed to be a discussion document. It's not salesy. It's actually the numbers. It's the crossing the chasm economic arguments and considerations. It's not an entertaining read, but it's actually something which where numbers are important to that chasm. It's important for us to show generally that this does make sense. If we can't show that it makes sense, then we've obviously made one of those. We've fallen into the trap and made something that's useless. Behind this, there is an engine which generates the numbers. The numbers don't tell the lies because they represent money. If we've got our model right and we're keen to pump in specific figures for specific board production operations of specific volumes, specific design varieties, and so on, and then we can actually calculate specific conclusions for anybody who's considering digital. And if the numbers actually show that it's better for a rotogravure printer to actually print or to buy from one of the existing big vendors, or to actually put in a Satin or a high volume inkjet printer instead, the numbers will tell us. And there's no point in actually trying to put the wrong shaped solution into a problem. So we've looked at those operational benefits. We haven't really looked at the marketing benefits of different value created. So we focused entirely on cost, and that's end-to-end cost. So we've compared.
Yeah, we compared maximum net production times per day. So production time depending on capacity, and we will show that it's dramatically reducing the capacity, is dramatically reduced by lot size, which is not surprising. But it's very interesting to see how strong it depends on that. We look to the capital costs for the investment cost and for the running cost, and altogether we will see what at the end the cost for a yearly production of paper or buying in from paper would be.
Some of the issues are real. Some of the issues they're real obstacles and challenges. Some are incidental or misunderstandings, and some are emotional. They might be fear or simply prejudice or fear of change, because this is inkjet's often described in industry as a disruptive technology, and it is very disruptive here. What we're suggesting is it completely disrupts the supply chain. The traditional model of the few supplying the many, the print specialist, is that's been in place for a long time. It's proven, it's safe, it's where we are now. That was the same in the office when copying had to be done at a copy center, and you'd take your documents to have them copied, or your technical manuals or whatever. You take them to a specialist who would put them on an expensive piece of kit and have them printed, and then you take them back to the office. Or you'd have, if you're a big company, you'd have a print center inside the company. Now everybody does it at their desk, decentralized. You can do it in your home. During COVID, most people can print what they printed in the office in their home. Printing is not a specialist. When it matures, it's not a specialist area to be done by third-party specialists. It's generally something that is vertically integrated into the rest of the process. So we ask the question, who should do the printing and where? And that's the extent of the disruption that could be possible. It's quite a significant disruption potentially.
Yes, and you can decide where to print at the end. We will. This is a small preview before we go into the real numbers and we show how we came to that numbers. This is a preview of the result in with an example calculation of 10 million square meters per year, where you have 4 options. So 1 and 2 is buying paper from a printer. The printer, we showed that here it's already using digital printing. So it's 5 million is in engraver printing and 5 million is in digital printing. And there are for sure different prices in the market with different either it is a different printer, or is it different volumes you take from the printer. So there are, when you check for the high price or the low price, so it's something in between 10.5 and 6.5 million euros is what you have at the end, at cost of printed deco paper at the end of the year for 10 million. If you have an in-house printing high volume inkjet printing machine, this would be calculated more expensive because the capital cost, I give the answer in advance, but so you have 8 million euros cost per paper. With a Herman Satin line, this would be around 6 million euros. And the next pages, and Richard will explain how that is, how the calculation is done. Yeah.
Okay, we just if we just focus on these numbers here, this is based on the capital cost of the equipment and the volume that's produced, which in this case is 10 million. That's an arbitrary number. It could be 15, could be 20, could be 5. If it's 5, then this becomes worse. If it's 20, then this becomes better. So this gap will close the more volume you do. On the other hand, if you go above 20 to 30, 40, whatever, you could have 2 of these. So that number would be double, but then this number is higher than the analog print. So at worst case, to produce your own digital output without the margin from a third-party vendor is pretty much the same as would be charged from a gravure output with all of the restrictions of minimum order quantity. If you're buying on good terms, then you're paying more to produce in-house than you would be to buy gravure. On the other hand, if you're buying digitally printed from a print vendor, you're able to produce it at a fraction of that price. Obviously, if you bring everything in-house, you would be printing everything in a blended price, which gives you those savings. So let's look at what we've compared. There are many costs that go into a comparison between digital and gravure. Our interest is coming out with a conclusion that makes sense. We've surveyed quite a large number of board producing operations, and we've interrogated and explored and investigated and researched. Now, there are fixed and variable costs. There are direct material costs. That's where most comparison sort of starts and finishes. Material storage, material inventory, obsolescence, wastage, managing a supply chain with purchasing operations, gravure rollers, sleeves, tooling. Are they assets or liabilities? Overproduction and the storage thereof. So if you want to use 5 million square meters, how many square meters do you actually buy to then put through impregnation and then to press into board, and how much of it actually is put to one side? The volume
Everything starts with the price of the ink, Richard.
Yeah, it's not as simple as that though. It's not as simple as that. Everybody say you pay. Why would you pay 7 times as much for the ink? But the ink is more expensive to manufacture because it has to go through a print head with a non-contact printing process rather than be rolled on with a great big roller. But then the cost of the rollers has to be taken into account. Then there's the setup and downtime. There's the loss of opportunity and the loss of value. There are many costs that we can't possibly configure into our model. Now, what we've shown is if we focus on the 20% of major costs, not the 20% by value, but the 20% of the number of cost elements, we can get to a figure which is very, very close, in most cases to within 2 or 3% of the total reality. And that's tested by customers' own cost calculator models and our own more simple cost calculation model. It's not as simple as ink price. So what's driving this is the drive for variety. Carsten, do you want to step in here?
Yeah, the drive for variety is what we see is increasing and increasing. So 10 to 15 years ago, you have, as shown on the left, 8, 10 designs in your collection, and now the demand is there for much more different designs. Even if in wood everything is it's oak still, in flooring, for example, but the customers request more choice, more variety of different designs. You can be exclusive in one way, and we see that with our existing lines in the market, the printing lines, the customers that have digital printing lines, they have much more than 40 or 80 different designs. They produce customer related designs. One DIY market gets its own design and it's not comparable with a neighbor and with their competitor anymore. So this is a very strong sales argument, having digital. So the demand for a larger variety is very high. Ceramics tile printing is demonstrating that 100% of design tiles, or every tile that has a design on top, is digital. This 75% of all tiles is digital printed. So the 25 which are not digital printed are white, red, or black. Yeah, so unitone color. So in wood decor, or in the decor market, it is not even close to the 75%. It's far below 1%, which is digital. But the demand is very much higher, and this is concerned by the decor print supply. Yeah. So the way how you get your hands to decorate paper.
So everybody has the capability to produce designs, and we may have to we may go into discussions on that. But you can produce the designs. You can do that from your home PC if necessary. But there are various ways of producing the designs. It's the transmission of those designs into products, flooring products, furniture products. Now in ceramics, there was an explosion in the variety of design that took place over a period of 5 or 6 years. And those are easily translated because they're digital files, no tooling. Even the stupid ideas got to be printed onto ceramic tiles, and everybody's tastes differ. Now, wood-based decor is actually in many ways overlapping and in competition with ceramics, and I think ceramics has shown growth where it was in decline before. There are other factors too, but it was in decline, but it showed growth because design was introduced as a selling variable. Wood decor is probably through constraints on technology in some parts, but also on the supply chain of printed paper to decor board production, and that's the problem, and that's what we're trying to address. So just to illustrate that, we've got here a diagram that came from Interprint. It was presented at IMI a couple of years ago. What it actually shows is the traditional gravure base is in lot sizes of 3 tons plus. That's where gravure works fantastically. It's lowest cost materials, and if you've got the volume and if you can keep the machines running with high uptime and high output, then it's fantastic for that. So those commodity products which have the volume, gravure is perfect. However, the growth is to the left of that 3 ton mark, and we're looking at a ton below. There's a lot of demand and a lot of unfulfilled demand. That's the gap. That's the problem for short runs, either for logistics, inventory reasons, or for design variety and customer reasons, market demand reasons. But there's a lot of demand in that sector, which is just simply not economical in gravure. The bit in between 1 and 3 tons, so up to 50,000 meters, that's actually the gray area. That's the bit where rotogravure really struggles with downtime from clean down and make ready, and the proportion of the time the machine is actually running sellable output. So towards the 1 ton, it's just not economical. 3 tons, just about. So that's really the issue. So the minimum order quantities from print vendors is not because they want to. It's not because they're sitting on their hands and just wanting the world to be as it was. It's because they really struggle with their technologies, and that's why they've all tried. They've all ventured into inkjet, into the high volume inkjet, so that they can take the loading of those jobs from the rotogravure to have the rotogravure much more slick and efficient. And we come on to some examples.
Yeah. So this is showing why that is, why that high volume is working very good, and this is how Graver worked in the past. You had very long runs over 5 hours, 7 hours, and when the printer was happy, he printed 24 hours, the same design. But the makeover time is, the setup time is quite high. But with long runs, it compensates, and so it was typically that they produced 2 designs per day, so 14 hours real production. What is it today? What is it today is that they have the short runs, but the same makeover times. So they are not able to produce the same hours because they have a lot of changeover times and only, in this example, 7 hours per real production. And the waste of material for makeover and the paper for the start print and running on capacity and running on speed and everything, this is a lot of material waste. So
that's material waste, that's paper, inks, and also energy as well.
Yes, energy is a big point. So you cannot turn off the dryers during your trimming session. Yeah. So digital printing is even more effective in that. It has a very short makeover time. So you can run, in this case, in this example, 19 hours, over 19 hours in production. But you can exactly fulfill the demand of multiple designs per day, and the design demand we have. The statement of Interprint during the IMI was that the make-ready process requires more time than printing, and even with streamlined Graver press production, we cannot keep up with the market requirements for short, long run lengths. These are statements which are really from the market, and we hear that not only from them. We produce the course in less time to reduce time for the market. That is because they are running digital printing, and they free up the Graver presses while using digital printing for short runs.
There's one other point in there, Carsten, is that each design tends to be printed on a particular sort of paper. So in some cases, you can't just standardize on the paper. That's the way it's been in the past. But we feel that there is a great opportunity to standardize on the paper and adjust the color through the color management in a digital system, so that you can actually have a rainbow roll with every design on the same paper. That simplifies the paper buying, simplifies the supply, and it also simplifies the downstream processes of impregnation and pressing. So there are further opportunities to economize and improve efficiency, but they're not built into this model. That's in a whole different dimension. But what you can see is there that the statement that Interprint, one of the major players in this, they can't keep up with market requirements. You see that it's changed from past to present, but the present to the future, we can only see that will change further. There'll be more demand for short runs. There'll be more demand for variety, and that's in tune with every other industry that industrial print serves. So we can see the capability is going to have an increasing tension with market demand. The two are becoming further apart because the market is moving faster. So we're going to some of the specific numbers here. Here's a gravure press, and as I said, for 150,000 meter job size, then theoretical capacity, net capacity, is 158 million square meters per year, and that will be the lowest cost. That's perfect for that type of job. That's why it was adopted in the first place. If you see to the right, all we've done here, everything else is the same. We've changed the job size down to 10,000 meters. If you change to 10,000 meters, you see just here the percentage downtime through change and making ready is 91.5%. That means your net output, usable output, is 23 million. 23 million square meters per year. That's a significant change from this. You see, it's 40% downtime for the big jobs, but it's 90-something% down from the small jobs. That really is the problem. Put in a different form, same here. If you take a 14,000 meter job, which is a ton of paper, or a 3,000 meter job, which is roughly a quarter of a ton, you've got, for gravure, 23 minutes printing, which is fantastic. But it's 6 hours setup. For inkjet, it's 20 minutes setup, and you've got between 45 minutes for a high volume inkjet, a fast inkjet machine, and for Satin, which is designed to be slower and steadier, 3 hours. So you see, on a 14,000 meter job, it's balanced. Don't forget, this is the throughput is balanced to the needs of the post process, the impregnation laminating. But you've got something which can work steadier and still achieve a better time than the rotogravure. So we're really looking here at a tortoise and hare situation. When you go to 3,000 meters, which we think is where things will go towards, they'll tend towards the smaller lots. You can see it gets even worse. So what takes half an hour on a high volume inkjet or an hour on a Satin takes 6 hours on a gravure, and most of that is setting up. If you had to set up for 6 hours to do 5 minutes of printing, it just simply wouldn't work. It wouldn't be worth it. It'd be soul destroying.
As we said, that typically no one would buy 3,000 square meters from a deco printer, but when you go to your production and you plan your production because of your incoming orders, you will probably for sure go for 3,000 square meters to fulfill that production batch.
Yeah, you have to look at the customers. If we skip back to that, Carsten, that's a good point. If you actually go to the end customer, how big is a room which needs flooring of 3,000 square meters? That's a very big room. So of course it could go through retail, it could go through architect specified construction projects or whatever. But 3,000 meters at end customer level is probably a large order. In the print industry, it's a very small order.
Yeah.
Sorry?
It's a reseller order, I think.
Yeah. So what the board producer it has demand for on a regular basis is orders of that size. What they tend to do is plan production, so they overproduce and put finished product into inventory. that automatically introduces risk, and it ties up cash. So economically, that is an inefficiency. So looking at capacity, we see here the three options: rotogravure, high volume inkjet, or Satin inkjet. And we see that if you run because of these loadings, we've taken here two jobs of it's all targeted around 10 million square meters a year. If you take half the jobs at 14,000 a ton and half the jobs at 3,000, of course, you're going to struggle to reach even 10 million square meters per year with a rotogravure running 18 shifts a week. With the high volume inkjet, it's the opposite. In 5 shifts, so you could be finished halfway through the working week. You can produce twice as much. What that means is you have a high value piece of capital equipment that is underutilized, which is not efficient. So with Satin, with a throughput matched and balanced to the needs of post-processing and the whole end-to-end chain, you can produce 10 million square meters on 8 shifts per week. You could run extra shifts to increase. You could double up and have another machine. But it's designed for something that uses the asset through the whole of the working week and doesn't actually leave it idle for any time. The capital cost is very important. The capital cost is spread through the output. So if you're producing 10 million from a rotogravure press, then you've got a lot of capital cost invested in something that's the same output as something that could be a Satin at 3 million. So that has a massive effect on the efficiency and the cost effectiveness. Here's a model where we look at the finance and operating costs. Just taking that finance there, if you write down a gravure press over 10 years, which would be typical, it's a heavy piece of kit and they do last, so you can use it for 10 years more. If you actually compare that with a Satin or any of the inkjet options, we've written down over 5 years. That's not to say that the inkjet press won't last longer than 5 years, but it's a technology item, so it's common to actually write it down sooner to account for the risks of something new and better coming along. From the UV inkjet experience, Carsten, how old are the presses that you have in the market, the inkjet presses that you have in the market?
So the first press we sold in 2009, which is still running with good maintenancing and some small tweaks and refurbishment, but it's still running in 3-shift operation from 2009.
Yeah, so 10 years is possible, and you haven't got to end of life in. I think I can think of one machine that's got to end of life, but that's more of an operational change rather than anything else. But life shouldn't be a problem in these. They are maintainable, and we've got in there a cost at the bottom of there and wear and spare parts, which would include print heads on occasions as well.
We did have a question actually, Richard, about maintenance.
Yeah.
What the cost is comparable to rotogravure and all that, and what's the downtime and all this sort of stuff. I guess it depends on what the maintenance is for specifically, but
it's difficult to factor in what are the consumables in a gravure process because you actually have tool wear as well. So there are significant costs in a gravure, high-speed gravure, even from the fact that it's actually running at a large multiple of speed. So the engineering cost in that is and the sensitivity is actually high. So we looked at an aggregate of what people said their wear and spare parts were in that type of press, and we cross-checked it with other industries where rotogravure is used as well. In inkjet, we know more certainly because we actually have service arrangements with similar equipment to Satin. So we're quite confident of the wear and spare parts there.
And that's factored into your numbers, isn't it?
That's factored in. And we do know that because we actually ourselves have, as Rico, we actually have inkjet presses that do run at 150 meters a minute. So we know that there's a higher cost for higher speed in wear and spare parts and maintenance. So those are we have triangulation on those numbers. They're very round numbers, but there is we could put it to decimal places and pennies and things, but those are actually representative figures, and we're quite happy to investigate in closer detail. But the main costs are actually on the capital cost. And if you write down a 16 million asset over 10 years, you've got 1.6 million of financing cost. And if you are that cash costs money, any cash you use costs money. So we've taken a 3% interest rate. So that put together with the finance and debt depreciation over 10 years, it's 1.8 million per year. It's even higher for the inkjet because you've got lower throughput potentially, and it's written down over 5 years. So you've actually got between 1.7 and 2.3, depending on the type that you choose. For Satin, by virtue of the fact that it's actually a lower capital cost, and therefore your finance costs and depreciation goes down, we're at a third of a gravure press and a third of a high volume inkjet press. With a big factor in operating is energy, and we've talked about that. Apart from wear and spare parts, and also you're running in more shifts to actually keep up with the demand for a gravure press. So more shifts means a higher staffing cost. We've got a slightly higher staffing cost there, operator cost for Satin, because we're running 2 shifts. But there are more people involved in running a gravure press, and we've also got a higher energy cost because you can't just switch on the dryers when you're ready to print. It doesn't work that way. You can't switch temperature from 0 to room temperature to drying temperature. You have to stabilize the system. So a lot of the downtime is actually running the dryers. By the way, Satin uses infrared drying, so slightly different. Then we move on to the direct material cost. And as I said earlier, it's not the ink cost is often the superficial comparison. So if you look at 30 euros playing 4 euros, you'd say, well, that's a not right. We'll rule this out from the start, because why would we want to pay 7 or 8 times more for the same kind of colored liquid? Well, it's manufactured differently because it's delivered differently. There is also less wastage because what you print with inkjet ends up on the image. A lot of the gravure ink doesn't. But there is a material difference there, and that flows through to the figures. So that if you're comparing on material costs, then you can see at the bottom there, a small job with more wastage, then you end up with about the same price per square meter, or approaching the same price between inkjet and gravure. But if you're in the high, those big ideal for gravure jobs, the 150 meters squared, it's half the price, and that's not surprising. The premise here is that most of the jobs are not in that sweet spot for gravure. They're sliding down the scale towards lower lot sizes, which means that you've got more wastage in there. The wastage figures, incidentally, they're actually figures that we took a very cautious approach to. Some of the operators actually told us that there is far more waste than that. But as I said, there's an engine behind here. So what we'd like to do is we'd like to compare specifics for specific operations.
Yes, if some of you guys have interest in that, I can repeat that. We are happy to fill in your values in our engine, and then calculate with your values, every values we have, and compare the situation.
Okay, so one thing we haven't focused on here, if you create the designs, and there may be some questions about where the designs are created, by whom, whether they're available, because a lot of this is actually within the purchase price of the paper. It's actually managed as something that's applied on paper by the major print vendors. So the decor competence the area is where the designs are offered from the printers. There are plenty of alternatives for that, but one of the aspects, this has to be managed very carefully in the existing model, because every time you have a new design, you have new tooling. And we've taken a very cautious approach to design refresh there on the second line of 5% of the total jobs. In some cases, it's over 20% refresh. But having said that, some of the designs are more than one design per sleeve set, because all you do is you change the color of the ink. So you can produce something that is like a light oak or a darker oak with the same grain pattern from the same sleeve, but you change the ink. So not all design needs a new tool. So we've taken a conservative estimate there of 5% of the jobs. As demand for variety increases, of course, there is pressure for refreshing more of the range per season or even continuously. So if you take the gravure tooling cost of 40,000 euros per tool, with that conservative estimate, you've got an annual cost of 2.3 million euros for tooling up for design with gravure. Of course, tooling up for the design for inkjet is just a digital file, and that goes straight from the designer to the pre-press and color management. Putting all of that together in this model, this is what we previewed earlier. We've taken a blend of 1 ton and quarter-ton jobs for the 10 million total, and what we see here is a comparison. If you were running as a printer a gravure press against a high-volume inkjet against Satin, the total cost would be 9 million for the gravure, it would be 6 million for Satin, and it'd be something in between for the high-volume inkjet. And largely, the difference on the inkjet is caused by capital cost. Okay, so that's if you were using it, if as a board producer you brought any of these in, regardless of capacity. This is all at 10 million square meters. So if you brought any of these options in-house to take control of printing at the board producer, that's what the comparative cost would be. So the next question is where should it be done? Should we make it or should we buy it? So we've got, as Carsten mentioned before in the preview, we've got higher price and lower price, different terms for different customers, different lot sizes, different supplies, but we've split this up half and half, digital and analog. So you can see the costs above in the gray, you can see the printer's margin, and printers need to make a margin. You can see that margin seems to be typical to give a selling price for the printed output of analog between 35 cents and 50 cents, which we've cross-checked per square meter, which we've cross-checked with quite a few. That seems to be about the range for analog output. Now, we did find some digital output, which maybe is unclear about lot sizes and so on. But if you look at that, if you're getting 5 million for 80 cents, it's over 1.5 euros. Or it could be down to about €1, just under €1 per square meter. But we heard some that were, Carsten, I think, 3 euros per square meter.
How much and how often, and all about your contracts, and yeah.
Yeah. So we've taken an aggregate figure, and once again, we're quite happy to plug real figures for real board producers into the model to see how it looks. We've actually projected from cost forward with margin and cross-checked against some real buying prices in the market from board producers. So you'd be paying, if you buy from the traditional supply chain with a blend of digital and analog, you would expect to spend for 10 million square meters between 6.5 and 10.5 million euros. Okay, so roundabout 65 cents total cost up to €1, let's say, round figures. If you bring printing in-house, and you have a high volume inkjet, you'll spend for the same volume, you'll be doing it all digital at the same cost per square meter, regardless of lot size. Batch size of 1, as is often said about digital, you can produce very short runs, or you can produce very long runs in rainbow rolls that you can then impregnate and produce. So regardless of any other savings in process flow, you'll be spending 8 million for a high volume and under 6 million for a Satin. Okay, that's the same figure as above, 6 million, but the only difference is you're bringing it in-house. Now, of course, you could use Satin in the print service vendors, and we're not saying that this is a battle between the existing supply structures and a new framework where it rules them out. If the major print providers were to do what had been done in office printing and other sectors, they could run the service using digital in plant, in board producers plant. So a segregated room where they actually print the printed paper, they bring in white paper, they print the image onto the paper, and they supply to the impregnation and pressing line directly. That's the way to get the digital advantage by reducing the logistics and supply chain. So it could be done by a print operator, a print vendor, a third-party vendor on site, or it could be done in-house by the board producer. Either way, it delivers advantage. The final part of the equation here, and we could go into many other things, but the final part is inventory, the effect on inventory. If you buy printed paper from a third-party vendor in another country or far away with a long lead time, you have to keep the board production operation running. So you have to stock, including safety stock, which takes into account the lead time, but you're stocking finished paper with all of the value added into it, the printed image. It's got everything together. So typically you'd end up with, in this model, I won't go through the calculations here, but it's in the white paper to study, and we're quite happy to put in specific figures again. You'd end up with 1 million of inventory just on printed paper. This is in the 10 million square meter model again. If you go to the other end of the scale with a Satin printer, you're storing plain paper and you're putting the image on demand. You have to keep ink stock, you have to keep paper stock, and you print on demand. Your inventory can go down by 80+%. Now, we know that many board producers have targets to reduce inventory and to reduce wastage. In print on demand, there is no wastage or negligible wastage if it's managed correctly. And there's dramatically reduced off the scale reduction in inventory available from doing this in plant, whether it's through an operator or brought into the board producer's own operation.
Yeah. During our discussions with customers, we heard that from this 1 million inventory, we heard numbers of 5 to 15% obsolete materials, which are thrown away at the end of the year. So from 1 million, we can calculate what you throw away. This is more than the inventory of you have to hold with a Satin printing line.
Yeah.
Yeah. The conclusion of all of that, of all the calculations, it was quite a lot of numbers. I hope it was good to follow up, and you can read that, and we are happy to, if you request, to send the white paper out at the end. The conclusion of that is that we've seen, or we are sure, and we demonstrated that there is no one will speak against that. I think there is the demand for a larger variety, for more variety of decorative surfaces, and the digital printing is technically proven, and I think with that calculation we can show that it pays off due to inventory, print on demand, less wastage, lower energy consumption, the carbon footprint, the green part in that we haven't really bespoken, which is also a big part in that. Yes.
Does the green part actually apply in the US? I don't think it's as important there. That was a joke, by the way.
Yeah, and comparing inkjet printing and Satin printing with other technologies shows that there is really the need to move it to the far end of the process chain. And the core question is what is blocking that? And with that document, we want to show help to understand the benefits.
Yeah, Carsten, we just to elaborate on that, we're really keen to plug in some real numbers from anybody who's interested to carry out their own specific study. But I think we can, if the numbers actually say that some other solution is better, then fine. The numbers are the truth. If they show it's cost viable, then really, technically proven there is in bold, and we're quite confident of that. We're not trying to print at breakneck speeds. Putting small drops of ink onto paper at very high speed is very clever. We're going slower. So we're pretty confident that we've taken away one of the major sources of unreliability, and we've balanced it to the line. So we're pretty confident we can prove technically, and we want specifically to prove economically, to cross the chasm, so that we can get this into mainstream use. to give the capability for the wood decor industry to actually do something with it and to meet the demand for some of that variety of design. There is a thing here is that if there is a cost of missing out, so if some do it and some don't, the ones that don't do it, they could focus on the low-cost commodity products with the same design, kind of like North Korean similarity. There is a place for that commodity product. We haven't even gone into the value add from design here, but I think that there are plenty of examples from.
Nice question here, leading on from that. So in terms of approaching customers, is your marketing focused on printers or board producers? Just a quick question there. For both. Okay.
So the core is the decentralization. So the operation where locally the machine has to be placed is closer to the end of the process chain, but it can be operated by the printers. Yeah. So it's what we think it's a good choice, and one way to go is that that a printer, which is now a traditional printer, operates with a customer together a local site feeding printing machine. Yeah. So the printers have the experience in design. That's something which is their basic knowledge, and they could assist, and they can operate it closer. And Richard can even explain it more. And in desktop printing and or in office printing, it's exactly the same. I think 50, or I don't know if it's more than 50%, are not buying printers. They are running the printer, which is placed by Rico or others. Yeah.
Yeah, that's right. I mean, it's pretty common in other sectors. In the carpeted world of the office, that nobody buys printers. They buy the output from printers on a click model, on agreed contracts, service contracts. That's pretty common amongst all of the major vendors, Rico being one of them. It's not necessarily the case that it's better for a board producer to actually make their own print shop. Of course, some will want to, and that's fine. So others may not want to, and as Carsten says, some of the big vendors, the print vendors, they actually have lots of things to bring to this as well. So this is not it's not intended to be working against anything. I think that the big print vendors, if they had a mind to do it, could do what has been done in the office environment, in the industrial environment, in decor, as we're proposing in other sectors as well, other application sectors, other industries, where printing is not a specialism, but it does make sense if you print close to the point of consumption. So if you print close to where the paper that's printed is going to be used, or the material that's printed. So whoever operates it, that's another question. We could go back to the slide on make or buy. There's a blend there that's possible, a third way, where you could actually have a blend of the two. And that's just a commercial arrangement. But all we're saying is it makes sense to print it decentralized.
Particularly so at the moment where, you know, the supply chains have been exposed, and flexibility is the order of the day, really, isn't it?
Yeah.
Just one other question about design cost. Any idea about design costs? Not necessarily the strength of an impregnator. I don't know if that makes sense to you.
I think it's also something which is Human's experience with digital printing since last 12 years, and many customers changed from being just the printed paper buyer. They moved over to introducing their own designs into the market. 10 years ago, it was difficult to get designs. That's to get your hand on digital files for designs. But the last years, it is more and more that independent design studios grow up. Ceramics market, as we said, is, I think, Richard, am I right? It's bigger market in volume than decorative market, or is the same size? I'm not sure. But
Well, I could say that it's difficult to measure, but there are something like 8,000 single-pass digital printers, inkjet printers, in the ceramics industry, and they're printing at similar speeds, if not faster, than Satin is proposed. By the way, it's not faster than Satin could print, but it's generally run by to match the pre and post processing in the ceramics industry. So if you say 8,000 machines are actually producing constantly 24/7 ceramic tiles with decoration on them, then you'd have to say that ceramics is getting a pretty good share of the market for interior surfaces. The design there was pretty well constrained in around about 2008, 2007. And then when the inkjet revolution happened in that sector, which was, by the way, in a construction recession caused by the economic crisis, it had to change, and it adopted new designs at a pace that I don't think anybody else has ever seen. The same thing could happen in packaging, but this was a response to opportunity. And I think in this case, if you've got the capability to do the design, I've seen personally, I've actually seen the type of digital files that go onto Decor. They're available for about €5,000 a design, Carsten.
yeah, maybe less.
Yeah, so it's no big deal, and there are companies that have grown as part of the ceramics field, and some of the wood decor surface manufacturers are also part of. They have ceramics also in their groups, so they'll be able to corroborate this. Design has followed closely behind the capability to produce. And I would say, compared to wood decor, the design capability that's in the markets for interior surfaces is there already. So it may not be the expertise of the current core expertise of an impregnator or pressing company, because it's actually in the past up until now been outsourced to a paper printer. But that's part of the proposition. You can carry on sourcing from the same place, and you could have an in-plant operation that's run with a digital printer balanced to the needs of an impregnation line, run by an existing vendor, or you can run it yourself. That's simply economic comparison.
Okay, well, thank you very much.
Just going through this, digital analogic is a term that we've mentioned.
Okay.
It's trying to fit digital into an analog space. We haven't done that. We've avoided that at all cost. This is decentralized. It's slow. It's designed to be flexible at a low capital cost. That's what it looks like. Carsten, you're pretty well ready to show people, yeah?
Yes, so we have that machine in a 1.30 m width. So it's our biggest lab machine we ever built. It's a 1.30 m wide single pass printing machine. So it could be a full operating 5-foot machine, 4-foot, sorry, machine. And ready now in house. We just in the last stage of powering up and doing our homework for installation, so the commissioning. We are ready in after the summer holidays for customer trials, and we are happy to invite everyone to see the machine, to look to the quality of print in person. Hopefully that traveling is not blocking us so much. But if not possible, then also we will make some ways of web meeting at the machine, web videos, live videos at the machine possible. And we are happy to discuss the document and the numbers in person with you. So yeah, come back to us and
if you send a short note to reply to on the invitation or whatever to either or any of us, and we've got contact details here, we can share the presentation. We can share the white paper or the red paper, whichever, the red covered white paper. And we're very, very keen to have individual discussions, as Carsten says. So
brilliant.
Thanks for your attention.
Well done, gentlemen. Very good, very thorough. And think that ends it. So thanks everybody for joining us today, and we shall follow up. And as the guys have said, happy to do a one-on-one through Microsoft Teams, or whatever. And so thanks very much, everybody, for your time. Cheers.